What's up guys, PC here, and today we're diving into DeepSeek, the AI that literally shook the US stock market by $1 trillion in just a matter of days. So let's not waste any more time and jump right into it. Now DeepSeek startups spent around 2.8 million GPU hours on training their language model. That would take one GPU more than 300 years to complete. But of course, they used around 2,000 GPUs, meaning it took them around 2 months to train their model. Now, is this number good? Is this bad? Well, let's compare it to Llama, for example. The largest Llama 3 model was trained with almost 31 million GPU hours. Now, that's 11 times more than DeepSeek. And on top of this, DeepSeek trained their model on inferior GPU chips due to the US export regulations. Nvidia cannot sell its most powerful GPUs to China, so instead of H100s, China gets less powerful H800s. Now the cost, these Nerve GPUs only cost $2 per hour, which brings DeepSeek's training bill to $5.6 million, which is orders of magnitude less than the training costs of models like GPT and Gemini. Now, until now, only big players could play in this game, like OpenAI, Google, and Meta could train such large language models due to their cost, but DeepSeek might just be changing that. With much less training time, cheaper GPUs, and models dominating benchmarks, they're now on par with OpenAI and Google's latest models. So how is this all possible? Because there are some caveats to unpack, including the actual training costs. But before we get into that, let's break down how DeepSeek models work and how are they so much faster. Now, DeepSeek recently published its two models, V3 and R1. Now, the V3 model, it is a third iteration of the main foundation language model, essentially their version of Llama or Gemini. Now, one of the key reasons why V3 is so much faster is its use of mixture of experts, or MOE. Now, what is an MOE? Now, MOE splits the model into smaller networks called experts, where each expert specializes in something different, like syntax, domain-specific knowledge, etc. Now, instead of passing input through all the experts, a router decides that which experts to activate based on the input. Now, why is that good? Okay, number one, it's better specialization because experts focus on specific tasks. Number two, massive computational savings because only a few experts are activated per input, reducing any unnecessary calculations. Now, this concept isn't actually new. It dates back to the early 90s and was used in models like Mixtral. However, MOE is hard to get right due to challenges like routing collapse and where the router only picks a few experts and ignores the rest. Now, DeepSeek solved this by increasing the number of experts, adding shared experts, which always gets selected for general knowledge, allowing non-shared experts to specialize. These allows DeepSeek to activate only 37 billion parameters at a time out of 671 billion total parameters, making the model highly efficient. However, you still need to load the full model when running it, as different experts get used over time. Now, let's talk about training in FP8, because DeepSeek's trained their model mostly on FP8 precision, but meaning 8-bit parameters instead of using FP16 or BF16. This doubles training speed, but it's harder to stabilize, so DeepSeek used a mixed precision approach where key computations were still done in a higher precision. If FP8 training becomes more reliable, everyone else will start using it for the huge speed improvements. Alright, now let's talk about R1 model, which is basically DeepSeek's reasoning model, which is kind of similar to OpenAI's O1 or O3. The key difference, instead of just spitting out answers, reasoning models generate intermediate steps allowing for self-reflection and better logical structure. Now, unlike OpenAI, which hides its internal reasoning, DeepSeek publishes everything, making it transparent and easier to replicate. Now, how did they train it? Okay, that's a billion-dollar question. So instead of using expensive human-annotated reasoning data, they relied on reinforcement learning. The model generated many solutions and they were used a rule-based reward system to reinforce correct reasoning steps. Now here's a fascinating insight. During training, the model's response kept getting longer, showing that it was learning to reason in depth. Now, final results. R1 is nearly on par with OpenAI's reasoning model, though it still struggles with readability and language mixing. To fix this, they have added a small amount of human-supervised fine-tuning before reinforcement learning. Alright, now let's talk about model distillation, okay? Because DeepSeek also did one more big thing, that they distilled R1's reasoning ability into smaller models like Llama and Qwen, making it accessible to users who can't run the massive models by themselves. Hey, if you want to run locally, just run this. And boom, you have DeepSeek's distilled reasoning model running on your machine. Now, final thoughts about this. I say DeepSeek's impact, it's massive because $5.6 million is just a final training cost. But they likely spend much more on research, fine-tuning, and testing. Now, 15 trillion tokens of data processing also added to the cost, but their findings are public, meaning that the AI community benefits from their work, which is something that OpenAI promised that they would do, but they are kind of chasing money now. Anyways, DeepSeek is not just a random startup. They've published many research papers proving they're serious players. Their advanced GPU optimizations in PTX and intermediate instruction set for CUDA highlight their engineering talent. Most importantly, DeepSeek's lower the entry barrier for AI research. Before, only OpenAI, Google, and Meta could train these models. Now, others can join in the race as well. For instance, Hugging Face is already trying to reproduce R1, and even universities might enter the game. A university spending $5 million on AI research is much more feasible than, let's say, spending billions. So yeah, that's been it for today, guys. Thank you for watching, and I'll see you tomorrow. Bye.